Use implicit differentiation to find the first derivative and the second derivative. So of course we'll start by finding the first derivative. We like this type of equation because the x terms and the y terms are separate, so we're just going to do power rule for derivatives. Remember, anytime that I take the derivative of a y term, I will carry around the y prime, which is the same as saying dy over dx. Of course, if you want to carry your dy and dx separately and then combine it into one, you are free to do so. So I have 4x squared plus 3y squared equals 9. I start with the derivative of 4x squared, so that's 4 times 2, which is 8. Keep the x, take 1 off of the power, and it's just a 1. Plus 3y squared, the derivative of 3y squared was 3 times 2, which is 6. Keep the y, take 1 off of the power, but because this is a y term, I'm going to multiply it by y prime. That is my dy over dx equals derivative of 9 is 0. So then I will separate everybody away from y prime. And I end up with y prime equals negative 4x over 3y. Remember, y prime is the same as saying dy over dx. So here is our first derivative. In order to find the second derivative, we're going to actually start here. So look, I'll rewrite it actually. Let me rewrite it right here. Now, notice that I'm telling you y prime is the same as dy over dx. That means y double prime is the same as the second derivative. So I could have left this as y prime and then found y double prime. It's just notation. So I'll go ahead and find the second derivative. This time I have to use quotient rule. I will go ahead and square my bottom so I don't forget. Then quotient rule says derivative of the top, that's negative 4, times original bottom, or regular bottom, minus derivative of the bottom, times original top. So one more time, derivative of the numerator, the derivative of negative 4x is negative 4, times original bottom, which is 3y, minus the derivative of the bottom. Well, the derivative of 3y is really 3, but because I am doing the derivative of a y term, I attach my y prime times original numerator, all over the bottom squared. So of course we can clean this up. Negative 12y plus 12xy prime all over 9y squared. And because I'm human, I need to check my work. I make mistakes. Negative 12y, positive 12xy prime. All right, one last step to do. I have a y prime here. Instead of the y prime, I'm going to replace it with what y prime actually is, negative 4x over 3y. And I'll end up with the second derivative is equal to negative 12y plus 12x times negative 4x over 3y all over 9y squared. And of course, you can clean this up and call that negative 48x squared all over 3y. And if you want to, you can combine the fractions in the numerator and then combine the whole thing. Or you can leave it like this. I guess it all depends on your particular instructor. If I'm your professor, you can actually leave it like this. Let's avoid trying to simplify it. We can make mistakes. But of course, if you're into that kind of thing, you can. All right, so one more time, we found the first derivative and the second derivative. I like to carry the y prime term instead of doing dy and dx separately. All right, hopefully this has been helpful.